So 3.5, solving quadratic equations. We finished this example. We're on to this one. This example here, before I start example 4, I want to go through this little box. Last year in grade 10, when we did consecutive integers, we knew what those meant. So consecutive, I'm just reviewing that word then. Consecutive means in a row. So if I said, what are 3 consecutive numbers? You could say 3, 4, 5. 5, 6, 7, 11, 12, 13. So consecutive means in a row. When you write that with a variable, you're going to go x plus 1. Those are consecutive. If I wanted to do 3 and do one more, I would do x plus, what would I do? 2. Good. Right? Etc. So those are consecutive integers. So that we know from last year. Now, we did do even and odd last year, but we didn't really define it that well. So now that we're in grade 11, I want to define this a little bit better. So when I say consecutive even integer, I want you to use this. So even means that 2 times something will always make something even, right? If you have any number and you multiply it by 2, it automatically makes it even. Right? If I have 17 and I multiply it by 2, that will make it 34. If I have 7 multiplied by 2, 14. Whenever you multiply something by 2, it automatically makes it even. So that is actually the definition of an even number, something that has got double in it. So an even number has a 2. So this is actually the definition of an even number, 2x. So to get the next even number, you would add 2 to it, not 1. Right? So if you add 1 to it, it would go to the odd number. So say, for instance, just looking for my paper, right? If I had the even number 8, and I wanted to get to the next consecutive means in a row, even number. I want to get to 10. How do I get to 10? I would add 2, right? To get to 10. And then how would I get to the next number? I would add 2. Does that make sense? So to get to 12. But the first number that you use, I don't want you using x. X is kind of too general. X just says it's some variable. When you use 2x, you're calling it an even number. So this is when I say 2 even numbers. That's the definition of an even number. So you might be like, but then what's the definition of a odd number? An odd number is defined by this. It's defined by 2x plus 1. So it's double something, but add 1 to it. Anything that's times 2 makes it even, and as soon as you add 1 to an even number, so try any even number. Give me an even number. 14. Add 1 to it, it's odd. So if you take any even number and you add 1 to it, it makes it odd. So the definition of an odd number is 2x plus 1. So you start with this. To get to the next even number, you add 2 to it. So you add 2. So you're adding 2, right? So if I had 15 and I want to get to the next odd number, what if you add 1 to it? No. You would add 2 and you would get to 17. How would you get to the next number? 19. So you would add 2. Does that make sense? All right? So these are different and they're definitions. So I do need you to remember it. I know it's different than what we did last year. Last year we were just like x is just the number. It doesn't matter if it's even and odd. But now if I say even, I want you to use 2x, okay, as your first starting one. And if I say odd, I want you to use 2x plus 1 as your first starting one. Okay, and that's just a definition. Okay, so we want to get used to that. That's how it'll be from now on when I do even and odds. Okay, so that again, I know it's a little different, and we did not do that last year at all. We just said x was whatever number. Okay, so from that, I said I want you to find the sum of the squares. We know sum means addition, right? Of the squares. So we're adding and we're squares of 2 consecutive odd numbers. And then is means equals, of course, right? So is means equals. So I want you to add the squares of 2 consecutive odd numbers. So when you see consecutive odd, so as soon as you see odd, you go, up. That's the one she wanted me to define as 2x plus 1. So as soon as I see that, I go 2x plus 1. That's my brain going, you want me to start with that. So start with 2x plus 1, and then the next consecutive would be 2x plus 3, right? Not 2, because then you're going to skip. So you're 2x plus 3. So we know add 2 to it, we're going to get to the next one. So let's set our let statement. So we're going to go let. And again, when you're doing the word problems and you're not sure how long it's going to be, start your answer kind of on the left side of your space. So especially since we seem to give horizontal spaces more, I'm going to start it here, and that way if I need to do more room, I can do columns. Right, so I'm going to go over here. People start their answers in the middle and then go, I ran out of room and both sides are now cramped. So I start it kind of on the left. So I go let 2x plus 1. That'll be my first odd integer, right? And how many do I want? 2 of them. So then the next one, you don't have to show this, but I'm saying the next one would be plus 2, right? To skip one. So again, that's my thinking. You don't have to show that, but it'll be 2x plus 1, comma, 2x plus 3 represent, you can say rep as short form for represent, the consecutive odd integers. Okay, so 2x plus 1 and 2x plus 3 are the consecutive odd integers. Okay? All right. Then I want to do the sum of the squares. Sum means add the squares. Add the squares together. So I'm going to take this first one here, and I'm going to do my equation. So it'll be 2x plus 1, square it, plus 2x plus 3, and square it. So sum, add the squares, equals 514. This is a solving question, so we're just going to solve for it. Right, so we're just going to solve for it. There's no vertex. So again, tell yourself it's not a vertex question, so you're not doing vertex x equals nothing. Okay, we're just going to solve. So we're going to expand it, collect like terms, and then use either factoring or quadratic equation. So we're going to bring this in. So how do I square this? It's a binomial squared. Right, binomial squared means I'm going to get 4x squared. What's the middle term? 4x. Good. Never forget that. Plus 1. Then here, 2x squared is 4x squared. The middle term, 2 times 3 is 6. Twice that, 12x. Is that okay? Okay, the middle term, plus 9. I'm just going to highlight this. So this part here is this part here, right? And then this part here is this part here, in case you're wondering where I got those from. So I just expanded those. Is that all right? And then equals 514. So this binomial square, don't forget the middle term. Please, please, please. It throws off your whole answer. You won't get integers. It'll be a mess. Okay? This one here, 2x times 3 is 6, and then twice it is 12. Okay. Then we're going to add the like terms. So 4x squared plus 4x squared, so we're good there, is going to get me 8x squared. 4x plus 12x, 16x, plus 10, and I'm going to bring this over, so minus 514 equals 0. Okay, next one. Keep going, so we're going to go 8x squared plus 16x, and that'll be negative 504. All right, so we want to either factor this or quadratic formula. Can 8 go into all of them? Always double check. I see an 8 here and 8 here. 504 divided by 8. So that one might need a calculator. 504 divided by 8, or long division. 63. So nice, right? So when you divide by the 8, you can either cancel it away first. Sometimes what I do is I factor it out so you can see better. So x squared 2x minus 63, like that. So you can factor it, but then you're allowed to cancel it because you're allowed to divide by a number. Does that make sense? You're allowed to divide both sides by 8. Okay. Not a letter. You're allowed to divide by a number, though. That's 0 still, right? So then you're left with, and that's factorable, right? So that's easy to factor. So we're going to go x plus 9, x minus 7. And then we can answer this. So we're going to say, okay, so now we've got our answers for this. So this is going to get me x equals negative 9, right? And then and 7. So here at 7. So we have 2 answers, right? So we get these lovely answers there. So therefore x is negative 9 and 7. Now, this is the case that contrasted with the example above, right? So this one, we got 62 and 24. And I said, are they a matching pair? And then I went back to check the y and went, oh, when I have 62, the other number is 24. When I have 24, 86 minus 24 is the other number. So this didn't get me another answer. It was still 62 and 24. Here, though, when I have negative 9 and 7, are they a matching pair? Are they consecutive odd numbers? No, they're not even consecutive at all, right? They're not beside each other. So they're definitely not a matching pair. Yep.
Why is like the 9 negative?
When you solve this, you take the x plus 9 out. So over here, x plus 9 equals 0. Just like when we did restrictions, bring the 9 over, it's negative 9, right? So each one you're doing like a restriction for, but it's not a restriction, you're solving, right? And same with that one. Okay. So then when we find this, those are not consecutive. You actually have 2 sets of answers. So you're going to now find your answers. And I do want you to set it up so I can read it. So you're going to say, find what? What am I finding? What's x? Which number is x? Neither. It's 2x plus 1 and 2x plus 3. I have to find both of those numbers. These are not the numbers at all. These are my x's for the numbers. So we're not there yet. So over here, I'm actually going to go up here. I'm going to do this instead because I realize this is going to take too much room. And I need to find my sets of numbers. So sometimes that's why I said going left to right sometimes gives me more room. So when x equals negative 9, we're going to find the numbers. Okay, and I'm also going to do that here for the next one when I'm going to do x equals 7. So 2 sets of answers. I want to find the numbers. Go back to your let statement. Make sure you look at your let statement and say, what did I find? Oh, wait, those are not the numbers I'm looking for. What am I asked for? Find the integers. I said these are my integers, so make sure, right? So make sure you look, I'll put the eyeballs, you look, smiling because we're doing math, there's your eyelashes. Look at your sentence. Okay, I'm doing that just so you remember, you're like, what was that silly thing she did? Look at your sentence. You said it, and then sometimes you go, the numbers are negative 9 and 7. No, they're not. You said these are my consecutive odd numbers. Look at what you wrote. So please look at what you wrote. You said those are my consecutive. So I need you to go back and find these. So then you're going to go 2x plus 1 is 2 times negative 9 plus 1. Negative 18 plus 1 is negative 17. And then 2x plus 3, negative 8. Oh, sorry, plus 3 is negative 15. Are those 2 consecutive odd numbers? There they are, negative 17 and negative 15. Those 2 are consecutive. Not these 2, right? These are not the consecutive odd. You weren't done. Look at your sentence. You said those are the consecutive odd numbers, not x. So then here, you're going to go 2x plus 1. So you're going to find those 2 numbers. 2 times 7 plus 1 is 14 plus 1 is 15. And 2x plus 3 is 2 times 7 plus 3, 14 plus 3, which is 17. Look at that. I have two separate sets of numbers. So you end up having this set of numbers, which I use the let statement to go back, to go back here and look. Those two are the two numbers I found with using -9. I used 7. I went back to my let statement, put it back in here, and that's where I got my next set. When you write your answer, so final step, write your answer. When you write your answer, if you write the numbers are -17, -15, 15, 17, it's wrong. You're going to lose a mark because you're not putting it together properly. This is actually two sets of numbers. You cannot say, don't say this. The numbers are -17, -15, 15, 17. Those are not the numbers. You have to separate them. So don't put it all together as 4. You have to separate them into two sets, right? The two consecutive odd numbers. So you're going to say, therefore, the integers are -15 and -17. That's a set. Or 15 and 17. That's a set. Do you see how that makes more sense in the sentence? If you list all 4, they're not all consecutive. It's these guys together and these guys together. You have to do a sentence that it has to be a clear sentence with no symbols, but also to make sense. If you list all 4 together, you're saying all 4 are consecutive to integers. That's not. Okay, so just at the last part, you don't want to lose the marks because you said it all together. Two sets of answers. Okay? Okay, I think I'm going to, should I try to do this on the same video or pause it? Maybe I'll pause it.